Okay, so now we're on lesson 2-3 on page 22 in your book. We are going to, let me get my writing pencil here. Let's unpack our learning targets. We're going to solve complex equations with variables on both sides, and then we're going to justify each step in the solution process. We're going to write and solve an equation to model a real-world situation. Okay, so we're still solving equations, but today we're going to look at some complex equations, and you'll see what that is in just a second. So let's look at the math tip over here. If an equation includes the product of a number and expression in parentheses, you can simplify by applying the distributive property. Okay, you distribute the A into B and get AB plus AC. That should look familiar to you. A times B plus A times C. So we're going to look at distribution today. Okay, some equations require multiple steps to solve them efficiently. Now, again, go back and watch the Khan Academy videos if you haven't already. Those videos go into more detail and show you step by step if you're still having trouble understanding this concept. Okay, so the equation 3x minus 2 times x plus 3 equals 5 minus 2x is solved in the table below. Complete the table by stating a property. Again, I don't want you to focus so much. I'm going to erase that. I don't want you to focus so much on identifying the properties as long as you are able to evaluate equations by using the properties. Okay, so this is a chart that shows all of these step-by-steps on how to solve this equation. So you first want to distribute. You need to distribute before you do anything else. You need to distribute the -2 into x and the -2 into +3. That is where this -2x and this -6 comes from. 3x, -2 times x is -2x. -2 times +3 is -6 equals 5 minus 2x. Then you need to combine like terms. You need to combine like terms after you do that, because now you have 3x minus 2x, which is 1x. Minus 6 equals 5 minus 2. Okay, now you need to move things around to where you have the term with the variable on one side and the constant on the other side. You can do this multiple ways. The way that the book shows you to do that is by adding 2x to both sides. So they started with adding 2x to both sides. I'm going to switch to red. They added 2x to both sides. And when you add 2x to both sides, the -2x plus 2x eliminates, and that leaves you, once you combine your like terms of 1x and 2x, that gives you the 3x. 3x minus 6 equals 5. Now you need to add 6 to both sides. When you add 6 to both sides, -6 plus 6 eliminates. Let me scroll down here for a second. -6x or -6 plus 6 eliminates, and that leaves you, you bring down your 3x equals 5 plus 6 is 11. Now, in order to isolate the variable x, you divide by 3. My operation here is multiplication, so I need to divide. The inverse operation of multiplication is division. When I divide both sides by 3, the 3's cancel, leaves me with x equals 11 divided by 3 simplifies to 3 2/3. There's multiple ways of solving this multi-step equation. You all have to distribute first and then combine like terms on the left side of the equal sign. But once you get to this step here, there's 4 ways that you can go from that point. As long as you end up with x equals 3 2/3, I don't care how you get there as long as you get there. Okay, there is no wrong way of solving. Well, I mean, there is a wrong way. There is a wrong way of solving this equation by not doing the correct thing, but there's 4 correct ways of solving this equation. Okay, now, number 2, part A, B, C, and D, solving equations. I want you to pause the video, and I want you to try to solve these equations on your own. Okay, I want you to solve these equations on your own and see if you can get to these problems. See if you can get to the values of the variables that you're solving for. You can eliminate the fractions in an equation by multiplying both sides of the equation by the least common denominator of the fraction, okay? Or you can leave the fractions in and simplify using the fractions. Okay, so I want you to do that. I want you to solve these equations, see if you can get to that point.
Coach Middleton, your Office Links delivery is in the office.
Okay, so now I'm going to solve part A for you. Okay, I'm going to solve part A for you. Part A was 5x plus 8 equals 3x minus 3. When you solve this multi-step equation, this is the way that I'm going to solve it. You can do it differently. I'm going to start off by subtracting. I'm going to change to a different pin number here. Subtracting 3x from both sides because I like to keep everything positive if I can. Okay, so 5x minus 3x is 2x. It's a 2x plus 8 equals 3x minus 3x eliminates, and that leaves you with negative 3. Make sure you include that negative sign. That is negative 3, not positive 3. Now I need to subtract 8. Now I'm going to go in the negative here, but that's okay because I was already at negative with the 3. Okay, now that leaves me with 2x. Positive 8 minus 8 eliminates and leaves you with just 2x on the left side equals negative 11. Now I'm going to isolate the variable x by dividing by 2, and my value for x is x equals negative 11 halves. Negative 11 halves. Now that is how I solve it. You can do it differently. You can start by subtracting 8 from both sides here. You can start by subtracting 5x. You can start by subtracting 3x, or you can start by adding 3. It doesn't matter where you start up here. You can start anywhere, and you should end up with negative 11 halves. Okay, that's part A. That is A. All right, B. Let me change back to black and write B. B is 2 with 4y plus 3 in parentheses equals 16. Now, the first thing you need to do is you need to distribute. Anytime you see a parentheses, you need to distribute. 2 times 4y is 8y. 2 times positive 3 is positive 6. Equals 16. Now this just becomes a simple two-step equation. I need to subtract 6 from both sides so that I can get my constants together. I'm left with 8y equals 10. 8y equals 10. Divide both sides by 8 to isolate my variable y, and I'm left with y equals 10 over 8. Now that simplifies to 5/4. So that's where you see 5/4 because 10/8 simplifies to 5/4. Okay, now I'm going to complete number C, or part C. Part C is a little more difficult, as you see, because you have fractions. And most of you are not fans of fractions, which is okay, but you've got to get used to it. You're going to see fractions this year, and you're going to see fractions a lot. Okay, so I'm going to leave the fractions as they are because it's not that bad. This looks scary, but it's really not. So I'm going to isolate the term with the variable. I'm going to subtract 1/5 from both sides. Because I have the common denominator already of 5, this is easy. I've got 2/3 p, because 1/5 minus 1/5 is 0, equals 4/5 minus 1/5 is 3/5. Okay, I apologize. I got interrupted by the intercom. I'm not sure where I ended off before it started. So I'm going to start here. When you subtract 1/5 from both sides, you get 4/5 minus 1/5, which is 3/5, because 4 minus 1 is 3. Keep my common denominator of 5. So 2/3 p equals 3/5. Now at this point, I want to multiply both sides of my equation by my reciprocal, which is just that fraction flipped, 2/3 to 3/2. When I do that, this eliminates on the left side and leaves me with my variable p. When you multiply by the reciprocal, the fractions eliminate. 3/5 times 3/2, when you multiply fractions, hopefully by now you know that you multiply straight across. So 3 times 3 is 9. 5 times 2 is 10. So my answer is 9/10. Okay, now part D. Part D is a little more difficult. Part D. Part D, you have 3/4 A minus 1/6 equals 2/3 A plus 1/4. A little more difficult because you don't have a common denominator, but I'm going to solve it leaving the fractions as is and not eliminating them, and you'll see why in just a second. Okay, so I'm going to start by, let's see, I'm going to start by adding 1/6. I'm going to add 1/6 to both sides, because that would help me keep a positive. Okay, this is what Mr. Witt chooses to do. I'm adding 1/6. Now I've got 3/4 A. 3/4 A remains the same. 1/6 cancels, equals 2/3 A stays the same. Now I need to add 1/4 and 1/6. 1/4 and 1/6. When I add 1/4 and 1/6, you need to get a common denominator in order to add. So my common denominator here is 12. Hopefully you know that the common denominator between 4 and 6 is 12. That is 12. So 1/4 is what? How many 12ths? Well, that's 3/12. My twos, there we go. 1/4 is 3/12. Okay, now I'm going to do a squiggly line so you know that this is another problem I'm doing over here. 3/12 plus 1/6. 1/6 is how many 12ths? Well, that's 2/12. Okay, so 3 and 2 makes 5. So now I'm left with 5, and what's my common denominator? 12. Okay, so 1/4 plus 1/6 is 5/12. Now, I need to subtract my 2/3 from both sides. When I subtract 2/3 from both sides, what is 3/4 minus 2/3? Well, let me do a squiggly again. My common denominator between 4 and 3 is, lo and behold, 12 again. Okay, so 4 would end up being 9/12. 3/4 is 9/12. 2/3 is 8/12. Negative 8/12. So what's 9/12 minus 8/12? Well, that's 1/12. 1/12 A. 1/12 A equals, those eliminate, 5/12. Okay. Now I'm going to multiply both sides by the reciprocal, which is 12 over 1. Multiply this side by 12 over 1. Okay. 12 over 1 times 1 over 12 eliminates, and that leaves me with A equals 5, because the 12s eliminate and leaves you with 5. So A equals 5. And that is part D. Now we're moving to page 23 in your book. 23 in your book. Let's see. Number 3, bags of maple granola cost $2 more than bags of apple granola. The owner of a restaurant ordered 6 bags of maple granola and 5 bags of apple granola. The total cost of the order was $56. Let M represent the cost of a bag of maple granola and write an expression for the cost of 6 bags of maple. Well, if M represents the cost of maple and I want to write an expression for the cost of 6 bags, it's just going to be 6 bags times M number of or M cost. So 6M, 6 bags of granola times M cost of each bag, 6M. Okay, use the variable M to write an expression for the cost of a bag of apple. Well, if a bag of apple, if you look up here, let me change my pen color to red so you can see it clearly. Okay, so bags of maple granola cost $2 more than bags of apple. So if a bag of maple is M dollars, because we got that from part A. M represents the cost of maple. So M, the cost of maple, minus 2 would give you the cost of apple. So we got M minus 2 equals apple. That expression represents the cost of apple granola. Now C, write an expression for the cost of 5 bags of apple granola. Well, if apple granola is M minus 2, 5 times 5 times M minus 2. M minus 2 represents the cost of apple. So cost of apple. That would be the expression to represent the cost of 5 bags, 5 times M minus 2. And then part D, write an equation to show the cost of 6 bags of maple granola and 5 bags of apple granola. Well, 6 bags of maple is going to be the 6M, 6 bags of maple, 6 times M, the cost of maple, plus 5 bags of M minus 2, 5 bags of apple, which is $2 less than maple, equals 56. Solve your equation and find the cost of bag for each apple and granola. So you need to find the cost of M, where M is the amount of maple. You need to have the cost of the maple in order to find the cost of the apple. Okay, you got to find the cost of maple because you can't find the cost of apple until you know the cost of maple, because the only information we've given is that apple is $2 less than maple. So M represents the cost of maple in this equation. So we need to solve this equation for M to see how much does maple cost. And then once we get the value for M for the cost of maple, then we can use that value to find the cost of apple. So when you solve this equation, I'm going to do it over here to the side. 6M plus 5M minus 2 equals 56. I first need to distribute the 5 and get 6M plus 5M minus 10 equals 56. Then I need to combine like terms and get 11M minus 10 equals 56. Now I need to add 10 to both sides, and I get 11M equals, these cancel, 66. Divide both sides by 11, and I get M equals 6. Ooh, that's funky. M equals 6. What does that mean? What does M equals 6 mean? Well, what does the variable M represent? M represents the cost of maple. So what does that mean? Maple costs $6. Well, if I know that maple costs $6, how can I find the cost of apple? Well, we know in this scenario that apple was $2 less than maple. So maple minus 2 equals apple. So 6, because M is 6, maple is $6, minus 2 is apple. So that means that apple is 4. Apple is $4. Okay, so that completes activity 2-3. I want you to do the check your understanding, number 4 and number 5, turn that in for classwork. And then you're going to do the activity 2-3 practice, which is on page 24, numbers 6 through 13, and turn that in for homework.